Hi, in this lesson we are going to look at arrays. In Java, arrays are objects. So we will look at objects before starting array. But before that, let's look at the reasons why we need arrays. Till now, to save any data, for example age or salary, we have been creating one variable to hold the data, right? So for example, say we have to find the average of 1000 numbers, 1000 integers. So do we create 1000 variables to save these 1000 integer values? That is not possible, right? We can't create those many variables, and the program will be full of variables only. There won't be any code to calculate the average. Okay. Also think of another situation, like we have to save the marks for a student for different subjects. So say there are 7 subjects. Generally in engineering we will have 7 subjects, right, for every semester. So we have to save those 7 values, but those 7 values are related, right? These 7 values are for a student marks in 7 subjects. Also we have internals, externals for every subject. So generally 14 different marks we have to save for a student. So do we create 14 variables for saving the marks for a student? No, we don't want to do that. Actually, we don't want to create those many variables. That is not the way to go. So those are the situations, or whenever we have to save same kind of data elements, we will consider arrays. So we create an array of that data type. As I said, in Java, arrays are objects. So let's look at a bit about objects. We are going to see them in PowerPoint presentation. As we are seeing the object or reference types for the first time, it is very important you know that how they are saved. You should be able to understand how the objects are represented and how the reference type variables works. Okay, let's go to the PowerPoint presentation. Okay, let's look at how we have been defining the primitive type variables and how the value is saved. We have seen it once when we introduced variables. Let's say we have a variable of int I. So when the variable declaration happened, a memory will be allocated for variable I. In this case, because it is an integer, the allocated memory is 4 bytes. Let's say the memory is allocated at address 100, but in Java we never see the address. So but every memory location has an address. For our example, we are going to say it is at address 100, even though we never look at that. Then let's say we have assigned a value of 10 to variable I. The 10 will be saved in the memory location that is allocated to I. So this is how primitive variables works. Okay, once we declare a variable, memory will be allocated. Whatever value we assign, the value will be saved in that memory location. This is very clear and very straightforward. Now let's look at reference types. First we are going to look at a simple reference type, that is date. Date is a class, and this is how we create a variable of reference type. In this case, the reference type is date. Okay, we created the variable. Do you see any difference between int I or date? The variable name is also date. There is no difference, right? Also, there is not much difference in the way the memory is allocated to that variable. Next, in case of primitive, I is of type int, we assigned a value of 10. Here we are using a integer literal, right? And we are assigning that value to I. What will we do in case of a reference type? In this case, date. We can't say date equal to something, right? We have to assign an object. Okay, because the date is a reference type, we have to create an object and assign the reference to that object to date variable. In Java, this is how we create a object using new keyword. We are creating a new object of type date and we are assigning the reference to date. Let's see what happens when this expression is evaluated or executed. New object will be created in heap memory. So again, here object is created at a different memory. Again, memory is allocated. We have to remember that whenever we create an object, memory will be allocated and object will be created. The object is created. Let's say object is created at address 400. Okay, this 400 will be saved in the memory allocated to the variable. That is how this variable of reference type is going to reference a object. Let's see this again. Okay, we created a variable of reference type, in this case date. Then we assigned a new object using the expression new date. When new date expression is evaluated, a new object is created in heap memory. Memory is allocated for this object and object is created at address 400. This 400 will be saved in the memory allocated for the variable. Using this address, our variable can point to the object. So this is what happens. In case of primitives, the value we are assigning will be saved in the memory. But in case of reference types, the address of the object will be saved in the variable. Okay, that is about date. Now let's look at arrays. Okay, arrays are objects. Nothing but here object will be created and object will be having the array. Let's look at that in detail. We are going to see the primitive type again. Int I, memory is allocated. We assigned value of 11. 11 is saved there. Then we have created an array of integer. So this is how we create an array of integer. In case of single primitive variable, we declared the variable using int I. But in case of array, we have to keep those square brackets to define a type of array. Okay, so this is how we define array of integers. If you see there is no size. We haven't mentioned anything inside brackets. So size is not part of the array. Okay, we will see that later. Okay, for variable a, the memory is allocated. Then we are assigning a new array, because as I said, array is object. Every object has to be created using the new keyword, or there is also some reflection API to create it a different way, but that is not the discussion here. This is how we create a new object, in this case array, and we are assigning that object reference to variable a. Here if you see, when we are creating the array, we have to mention the size. Without mentioning the size, the array won't be created. It will be a compile time error. So let's see what happens now once this statement is executed. New object will be created on heap memory and the address 200 will be saved in the variable memory. Okay, that's how the variable a is going to reference this array. Okay, now because we created an array of 3 integers, there are 3 memory locations available to save 3 integers. We can say 3 variables are created inside object, but those variables doesn't have any name. So we can call them nameless variables. Without name, we can't address them. We can't access them, right? The whatever value is saved there, we can't access them. Because they don't have a name, we have to access them using a index, array index. Okay, the first element can be accessed using a of 0. Nothing but index 0 is pointing to the first element. Using index 1, we can point to second element. Using index 2, we'll point to the third element. So for an array of size 3, the indexes are going to range from 0 to 2. So always the maximum index value is 1 less than the size of the array. Here if you see 3 is the size of the array, the maximum index is 2, that is 3 minus 1. When arrays are created, they will have a default value, because here it is an integer, it is having default value of 0 for all the elements. If it is a float array, it will have float value of 0.0 for all the elements. If it is a boolean array, it is going to have false for all the elements. If it is a object array or reference type array, for example, consider it is an array of strings, all the strings will be nulls. Okay, that is about object creation. Now, as I said, we are going to access these 3 elements using indexes. So we are assigning a of 0 a value of 23. So 23 will be saved at this location. We can assign a different value to a of 1, a of 2, and they will be saved in those 3 variables or in the array. Okay, let's say we want to change the size of the array. Okay, once array is created, it is fixed. The size is fixed. We can't change the size. Okay, now what we have to do is we have to create a new array and make the variable reference to that new object. Okay, here we are creating a new array of size 2. Okay, so if you see here, new object is created at address 204 and array of two integers is created and they are having a default value of 0 as we have seen before. Now address 204 is going to be saved in our variable a. Okay, so a is going to reference new object. What happens to the old object? In this case, old object doesn't have any reference, right? Nothing is pointing towards that object that is there at address 200. We created that object previously and we have taken that reference and saved it in a. Then we have assigned three values, but after that, all of a sudden we are pointing our variable a to a different object, different array with size 2. So what happens to the old object? Because there is no reference, it cannot be reached, right? There is no other variable to reach that object, so it cannot be reached, and this old object will be destroyed by garbage collector. Okay, Java, we have a garbage collector. It is going to claim all the objects that are not having any reference. Okay, when object is created using the new keyword, a memory is allocated. So once this object is no longer required, it has to be released. The memory has to be released. Otherwise what happens is all the memory will be occupied with unused objects and we will not have any memory to create the new objects. So this is also called memory leak. If there is a memory object, if memory is allocated to some object and that memory is never claimed, then that is going to become a memory leak. That shouldn't happen in programs, because what happens is when memory leak happens, we will lose some memory and new objects cannot be created down the line. Okay, in this case the old object is eligible for garbage collection and garbage collector will destroy that object and free the memory that was allocated to the old object. Okay, that is all about creating object and accessing variables. Let's see that in the code. Okay, this is how we create a variable of primitive type and this is how we assign the value. Okay, now let's create a array of integer. So this is how we define a type array of integer. Okay, this is a simple integer, this is a array of integer. Let's give it a name, array of integer, AI. So we are going to create an array of 5 elements, right? So we have seen that this is going to create an object and it will initiate values to 0. 5 integer values are there, all of them are 0. Let's look at that. As I said, the first element can be accessed using 0, right? Let me print this one value. Okay, this is 0. Okay, so let me print all the 5 values using a for loop. For int I equal to 0, because the index starts with 0, I less than or equal to 4, right? The maximum value is 4 and we have to go from 0 to 4. Then I plus plus, we want to go for every element, and instead of printing just 0th element, we are going to print ith element. So all 5 elements will be printed. Okay, all of them are 0, right? Let's see if it is a boolean value. Okay, so if it is a array of boolean values, here also we have to mention boolean. If we print, now all of them are going to be false. If it is float, all of them are going to be 0 0 0 0. If it is a string, all of them are null. Okay, it can be of date also, because string and date both are reference types. All these objects are referring to null. Okay, let's go back to our int. Before printing, let me say before assigning values. Okay, now we want to assign values. So a of 0, let's assign 10. A of 1, okay, we are accessing all the 5 elements and we have assigned values to all the 5 elements. Let's print it now. We are going to print the same array. So before assigning value, all the default values of 0. After assigning values, we got the values. Okay, by mistake, if we write 5 here, so we are trying to access an element in the array AI with index 5. So is there any element with index 5? No, because size of the array is 5. The index will start from 0 and will end with 5. If we try to access with an index 5, we are going to get an exception and the program will be terminated. This is the exception. It says array index out of bounds. So array index 5 is out of bound. Our boundary is at 4 only. So if we cross that boundary, we are going to get an exception. So make sure you never cross the boundary. As I said before, the arrays are of fixed size. So there is a variable. Okay, here instead of hard coding a and 4, I can use a dot length. Okay, so this is 5, right? I don't want to, what is the length? Length is 5. I don't want to go till 5. I have to stop at 4 only. So I have to write -1. So there are two idioms. So first one is either you write I less than or equal to length -1, or you will simply write a less than length or I less than length. So these are the two ways. Whatever way you prefer, you can write that. One is I less than length, another is I less than or equal to length -1. This is very explicit, saying the last index will be 1 less than the length. Okay, you can, whatever you prefer, you can write that. Okay, I'm going to print the same thing. Okay, we have already seen array index out of bounds, and also we have seen this is fixed length, and we can access that length using array dot length. Okay, now if we want to change the size, we have to create a new array and we have to assign it to AI. Whatever is the variable here, we have to assign it to that. So let's create a new array of integers. Let's say this time we want to create array with size 10. If we assign this new objects to this one, as we have seen in the PowerPoint, this new object is going to have all 0 values because that is a default value for int. So if we print that now, we are going to get 10 elements and all of them are going to be 0. Okay, here if you see, all of them are going to be 0. So whatever values we have assigned previously, they are all lost. We don't want that. I mean, we want to increase the array by creating new array. At the same time, we want to copy the old values into the new array. So what we have to do is, instead of assigning the new object to the existing variable, let's create a new variable. How do we create a variable that can point to a array of integer? Using int square brackets. Okay, so we will call this temporary array, and what we do is we will take all the existing values and we will assign them to this temporary array. This is how we copy element by element. Okay, because we have 5 elements, this copy expression has to execute for 5 times only. So remaining 5 elements in the new array, that is nothing but temporary array, are going to be 0. Let's print this temporary array once. Okay, so this temporary array is having the 5 values and the remaining elements are 0. So let's use the remaining elements also. Couple of remaining elements. So we want to save the 6th element at index 5 as 55 and last element at index 9 as 100. Let's execute. Okay, previously 5 values are copied, remaining all elements are with default values. Now first 5 elements are copied, 6th element and 10th element are assigned new values. Now we have two arrays here. One is being referenced by AI, array of integers, and another is referenced by temp array, right? We have two variables and they are referring to two objects, two different objects. Now what we can do is we can make AI refer to this temporary array. Okay, so now what is happening? In the previous case, we have seen that here we have seen that initially AI is created and this is pointing to 200. New temp array is created that is pointing to 204. When I use this expression A of AI equal to temp array, what happens is temp array is saving value of 204. AI is saving value of 200. 204 will be copied to this one and AI is going to reference to the new object. So once that copy happens, the old reference or old variable is going to point to new object, and first object will be eligible for garbage collection. So that is what happening here. We are making AI refer to the temporary array. So whatever object, whatever array previously AI is referring to, that is now eligible for garbage collection because that is not referenced by AI anymore. Okay, this is very important. Okay, now let's print AI. Okay, now AI is having 10 elements and the old values are saved as well as whatever new values we populated. So this is how we increase the array size. Okay, there is no other way. We have to create a new object. In this case, that object is nothing but array. We have to create a new array with bigger size and we have to copy our elements to that new array and make our variable point to the new array. Okay, now because I don't need to point to the object with two variables. Now AI is pointing to that new object. Temporary array is also pointing to the new object. I don't want temporary array variable pointing to that new object anymore. So how can I dereference that? By assigning a null. So once I assign null to a variable of reference type, this variable is not going to point to anything. Okay, previously this variable is pointing to array, the newly created array, but after this statement this is not going to point to that array. What happens is the new array will have null here and it won't point to any object. Okay, so this is how we make a variable not point to any object. At the beginning we have seen a array of strings, but let's create one more array. I am creating array of two strings. I am making first element save manohar, and second element is saving academy. Let's print those values in a loop. Okay, we can see Manohar Academy, two elements or two strings saved in array of strings. Okay, that is how we create single dimension, because this is a single dimensional array or simple array of fixed size. There is no array with variable length. This is a fixed size array, and this is how we assign values. This is how we access those values. This is how we access the length of the array, and this is how we will make it to point to a new array, and this is how we make it not to point to an array, and this is how we create array of objects. String is an object, right? String is not a primitive data type. String is a reference type and it is an object. So we have seen all those scenarios. I hope you understood the concept of arrays. Even you did not understand, you will be able to understand when we start writing some programs. We are going to write a lot of programs on arrays. Not only this simple array, we are going to create 2-dimensional arrays, 3-dimensional arrays, and we are going to play with it. Okay, so you are going to understand arrays. There is no problem, but try to make some changes to this program and understand it. Okay, thanks for watching. Please subscribe and share it with others.